I will speak about fire prevention, emergency procedure, first aid and rescue. I have to say it, I have confronted with the same situation in Switzerland. It's difficult. It's difficult to manage the safety. And what I present here, it's a high level of safety, and it's difficult to reach. On my side, I don't have really the optimum of safety. It has a cost. Safety has a cost. So I will present what is the standard according to the proposal of the ITA. But I have to say, it's not easy to reach. This standard is not easy to reach. Okay, I will speak what we can have for problem in tunnel. What are the possible emergency in tunnel? That I will speak about the management of emergency, of the organization of the management of the emergency. And I will speak a lot about fire, because fire is the main problem. If you have a fire in a tunnel, it's always catastrophic. Okay. What can we have for problems in tunnel, for accident? I have to say, the standard accident during tunnel construction is a traffic accident. It's a standard traffic accident. The problem in tunnel, it's very small, and there is machine moving, and very often that pedestrian people are blocked, are pressed by machines against the wall of the tunnel. That's a standard accident, and you can have an accident, two cars and a personal bus going in front of trucks. That's always a standard accident. That's not the accident with the mining equipment, or with there is accident, but not the main accident. The main accident is really the transport accident. Then you can have collapse. Collapse at the tunnel face or behind the tunnel face, or at the portal, as we saw. That's very dangerous. Then you can have failure of the permanent support, exactly, and you can have fire. Sometimes you can have explosion. If the explosives are not well managed, you can have risk of explosion, and you can have problem with water or mud inflow. It's the portal. So mud inflow in the portal which comes in the tunnel. After that, we can problem for power failures. That's normally not an accident. What is very dangerous is also oxygen deficiency, and you can have, if you have not a good ventilation, you can have problem. If you have small galleries let sometimes without no work, you have the risk. Or if the ventilation is cut, is not working, and the contractor decides to work, it's a big risk, oxygen deficiency. And sometimes you have misfire or explosive, but for me it's not an accident, it's a standard case in tunnel you have to manage. Okay, in all emergency, all problem of safety, the situation have to be planned in advance. So you have to define the chain of authority and communication for emergency. And one of the questions, who takes the lead, is the client or is the contractor? But you have to decide before. And it should be discussed with the public rescue service, with ambulance services, with firemen. Very important things, that these people have to be trained on site. They have to come on site, see how it looks. If they have to come one time, they have to know how it is. And if there is change, if you have a complex project, they have to come at each change. They have to be informed about the change. They have to be informed about how they have to be to go in the tunnel, how they can be oriented in the tunnel. They should know that. And you have to make emergency plan, contingency plan in advance. And it should always be prepared in advance. And the people have to be enforced about these emergency plans. I think that if you solve all these problems of all these points, you have done a lot of things. Most of the job is done. If you have complex project, for example, hydroelectrical project or complex tunnel, you should study every step of construction. So you have to define escape route in advance. You have to define the position of the meeting points for the people underground. And if there's a complex system, if you are not sure that the people can go outside, you have to install rescue chambers. And for example, in Switzerland, we said in a normal tunnel, standard tunnel, after 500 meters, the contractor have to install a rescue chambers. If there is a brand, a fire between the portal and the front, people have to go in these rescue chambers. And you have to define policies for using evacuation means. The goal is not to let all the people taking the cars and go away quickly. That's not good. If they do that, you will have accident or people staying alone in the tunnel. So you have to discuss, inform the worker what they have to do during an evacuation. And very important is the communication. The communication is the most important things in emergency, so you have to define the communication chain and the procedure of communication. Who speak with who, and who decide to use the communications system. And you have to be ready in advance. That's always the same rules. Okay. It could be done very, very quickly. Here, you have an example, it's on a project in Switzerland, of you have a big rescue chambers. So it's the question, it's the communication from the rescue chambers to the chief of the intervention, the chief of the fireman, and the fireman who go in tunnel, and after to the chief of the fireman, and to the client who pay, I have to say. And the problem we had here, so we don't know who will come in the rescue chambers, so we decide to organize in advance. So we train, we form some people to be the chief of the rescue chamber, to use the equipment of the rescue chamber, and this guy have to take contact with or we have to search contact outside, and the chief of intervention we give him order. And after that, the chief of intervention will give order to the ambulance, to the fireman, to the police, and also to the contractors. But it could be done in an easy way, like such diagram, but you have to define it in advance. Very important it's to say to the people, if you are in an emergency situation, where are the meeting points? Because if you have to search people, it is better that the people go on a defined place, that people are everywhere in the tunnel. So you have to define some place in the tunnel who are the meeting point. And this meeting point can be changed. That's an example from the Lötschberg-based tunnel. So you have a 4-kilometer access gallery with some working place in the gallery, and after that's the point of Verden, you have some working place in the tunnel. So we defined here 4 meeting points where the people have to go if there is an emergency. And you have to do the same for outside. First thing is, when people are coming outside, they have to meet in one point. One of the problems, if the people are outside, and you should know if they are in the tunnel or outside. So it's important to define when there is an emergency, where is the place the people have to meet. And here it's an example of in the installations place, a working site with several companies. That's electromechanical companies. So where is the meeting point? Where are the equipment? And where are, for example, where we have petrol for the engine? It's very important for the fireman to know that inside and outside, and where there is electrical equipment too. Okay. as I say, it's very standard in Europe to have rescue chambers in the tunnel. Rescue chamber can be very simple. It's a container, and the container should have redundant air supplies. They can have compressed air bottle, but it's not sufficient. They should have external air supply. And the external air supply have to be protected. And very important is to, when you decide such refuge chambers, is to choose the strategic situation. If you have such container, you have the advantage you can move the container during construction. So you have to plan where you will move your container. And one of the problems you have, it's sometimes complicated, but perhaps sometimes it's better to decide. I don't install one at one place and another to another place, because if I have only 20 seats, I say seats, or the place for 20 persons, and I have 40 persons underground, it's better to have two containers at the same place, because if you have 40 persons, you have the risk that 40 persons go in one container with this previous for 20. So it's important to think about such problem. Here, that's the example of Nordrhein. It's a region of the central part of the caverns. We can have 200 people underground at the same time. The contract previous only a chamber for 100 people, and I decide I want a chamber for 200. If I have 200 people underground, I need place for 200 people. And you can see here the equipment. We have a small equipment in it, material, but for sanitary purpose. And here you can here for these things we have two compressed air alimentation, compressed air supplied from two different portals. Okay. Actually, and now, how to prepare emergency plan? The first priority in emergency action is to minimize the risk to persons working underground. The machines, the equipment are not the problem. The people are the problem. You can, after you can call insurance to change the machine. You cannot change the people. What is very important is to know where are your people. If you are only one line tunnel, you can have outside everybody has a badge with his name, and let the badge is the office when you go in the tunnel, for example. But if you have a complex tunnel, you have to have sometimes things more precise. Another thing is to ensure the communication in file, even in event of power failure. You have to have always the communication with your people in the tunnel. You have to ensure that the people can follow the escape route. And if you are a complex tunnel system, you have to define some ventilation scenarios depending from the fire localization. And if you are only a one-line tunnel, somebody has to decide to stop or not the ventilation. You have to think that in advance. And if you need your ventilation, the ventilation has to run even in the event of a power failure. And for the fireman, it's very important to know if there is power or no electrical power in the tunnel. So you should install a clear labeling of your power supply. For complex tunnel systems, there is localization system to know where are your people. You have an electronic chips on your helmet, and so you can count and localize your people underground. In complex project in Western Europe is a standard. We have had that's what Lötschberg, Nandrans. So the management of the site, the fireman commandant could know where are the people. The problem, you have to be very strict with that. The people have to wear the badge. For example, they don't have to let the badge in the tunnel. They have to have the badge with them. The best thing is to install the badge on the helmet. Okay. Very important is to insert the communication between the people. So the best thing is to have minimum 2 communication systems and to have battery for power failures. The best one, you have a fixed telephone line and radios, for example. But you have to have 2 systems. And if all the people don't have radios or telephone, you have to find solution to alarm the people. And for example, with such a fire alarm, we make a lot of loud that the people know if there is a fire underground. And as always, emergency is the marking of lighting of escape route. They are very simple system. You can develop your own system, but there are standard labeling of escape route. You can use it. And for example, I know a contractor who use such green lamps. They function even in event of power failure, and he defines the escape route with this green lamp. And if there is no light, the people can follow these lamps. It's an example. And if you have complex galleries, you have to really make plans and communicate these drawings to the people in advance, and adapt them if necessary. Here, some example of ventilation scenario. The first thing is make it simple. Here, at the beginning of the project, we have 14 fire scenarios. And we work with firemen, and they say to us, it's too much, it's too complicated. Make it simple. So we decide to have after analyzing the system, we define to have only 2 scenarios. And if there is a fire, for example, in the tunnel in this part, we will inverse the ventilation and let the smoke goes out here. But it is a decision, and what we do here is, if there is a fire, the people will inform. There is a central control station and say where is the fire, and after the officer in the control station only press on his computer the name, types the name of the region, and the system goes automatically. And what we have to manage when we do such scenario of ventilation, you have to define escape routes to keep free of smoke. And on such system, one of the solutions to keep sectors without smoke is to have gates, and to control it from outside, and gate and locks. And so you can decide if you want to isolate a place as a region. You can confine this place without smokes. It's one of the solutions. What I will say too, and here we at this moment of the project, we have here one rescue chamber, and here in some other point we have some rescue containers. They are defined in advance, and they are also in the drawings. What is the goal of an emergency plan? They should insert that personnel you have to be ready for emergency, and so you have to prepare in advance equipment for rescue and for firefighting. And so you have to organize that, and one of the problems is to decide if you want to have equipment on site or not. But if the equipment are not on site, they have to be by the fireman, and they can be obtained with a telephone call. And another thing is very important is always the maintenance. So you have to organize the control and the maintenance of the equipment. First of all is the communication. If you have a big equipment but it's not running, it's for nothing. So you have to control that your communication equipment is running. Exactly for the power supply, you have to have perhaps additional power supply if necessary, and you have to monitor the atmospheric condition and the ventilation. If you have emergency chambers, you have to have air supply, so that you have to have compressor, and the compressor have to be controlled and maintained. Exactly for lighting, and you have to have a normal lighting and an emergency lighting, and you have to have firefighting equipment, and the firefighting equipment have to be controlled also, and if required, pump system. And so you have to organize the fire prevention at early project stage. It's for me, for the IT association, it's the client have to take the first contact with the public services. Not only the contractor, you have to discuss in advance with the public rescue services. And said the client has to define also his strategy on health and safety. Mr. Galler will speak about that. And he has to plan health and safety, take first decision for me before the tendering. And you have to discuss with the authority to define the chain and communication. If you have only one contractor, you can let that, as client, you can let that to the contractor. If there is several contractors, somebody has to take the lead, and normally it's the job of the client. And one of the decisions which is very important is to decide if you want to have an on-site rescue team or not, an on-site firefighting team or not. If you are far away from cities and there is no firefighting people on site, the best solution is to organize that on site. But the client has to write that in the tendering documents. If not, after that there is a lot of problem because when a fire occurs, who is responsible? We will pay. If it's defined that there is a firefighting time on site, in the tendering document, it's better. And there is also, during the design time, I think the client engineer have to make a first fire assessment and to identify what are the risks of fire. Have we natural gases? Have we methane? It's always the choice of the sealing material is also important. And you can also write something in the contract about ignition of fire. And after that, when the contractor is preparing his tendering, he has to make our risk assessment, and he has to decide for the safety measure. You have to make a risk mitigation, a planning of the safety measure. And after that, at the beginning of the execution, the acquisition of the safety material have to be initiated. So the basic equipment, I think, is that's a fire extinguisher. It's to stop a fire very quickly. One of the questions we had very often in Europe is oxygen self-rescue, if we need that or not. We normally, for example, in Switzerland, we do risk analysis of we need that or not. That you have to install alarm system and also atmospheric monitoring device. And very important is to make the formation of the key personnel and workmen. And another point I will come on that is the formation of the rescue and fire team. I have to say, for firemen, intervention underground is not simple and very complicated. It's not usual. And there is some special risk to come in tunnel. I don't know if you know this type of equipment. If you have that, for example, in Argentina, is a self-rescuer. It's allow people to go to breathe about half an hour to 1 hour, and it's allow people to go to a safe place if there is smoke. If there is smoke, you can take it. It's give oxygen to people to go out. It's not easy, but if you have that, you can save. You can rescue your people. They can rescue themselves, if possible. What you have to do during construction, you have to control the situation on site. If possible, with experts, with people of the, I have to say, with fireman expert. And one of the action to do is to reduce the quantities of flammable materials and to eliminate the potential ignition sources. And very important is to position the firefighting equipment at the right place. If you have done these three things on site, a lot of problem can be solved very quickly. And it's very important to evaluate and adapt the safety measure to the real situation. If you make exercise, if you control and you see it's not good, you have to change. You have to form your people, you have to form the rescue and firefighting teams. And you have to, for that, you have to organize exercise. And you have to learn from exercise. When you are doing exercise and on site, you will see the problem and will see the correction to do. Example of reduction of quantity of flammable material. Here, one of subcontractor let here material, that's wood, tires. That really, it's give a lot of smoke. That's really not good to let some things in a tunnel if you don't need it. If you need it, I can understand. If they don't need it, they have to take that out of the tunnel. And very important thing is to evacuate all the waste. Usually, don't wait a lot of time to evacuate the waste. Take it away as quick as possible. Another thing is here to eliminate the potential initiation sources. Here is cutting, the worker is cutting steel bars, but here there is plastics and such thing. And there is no fire extinguisher. You should avoid such situation. And somebody has to control that such situation didn't occur. And in the chassis of the trucks, you have also very often oil. They have to be kept, they have to be cleaned very frequently, very often, because if there is an ignition source, it will burn there. And a very simple example, that an Italian coffee bottle, that the people let that running, and it was completely red, and it can begin to fire. For example, you have to have somebody to control such thing and say to the people, don't make such idiotic things. One of the problems is. Petrol, diesel, and such things. Gasoline and petroleum gases are not allowed in tunnel. Sometimes you need gases, but gasolines never use gasoline in tunnel. Use diesel, and if possible, avoid to stock diesel in the gallery. If you have to use diesel to stock diesel in the galleries, you have to take measures to protect them. You have to have fire extinguisher. One of the questions I have here is the fire extinguisher at the right place. If the thing is burning, you cannot take it. But never use gasoline in tunnels. There is problem with the carbon monoxide, and it is easy to initiate a fire with gasoline. And for the formation of people, one of the better solutions is to use checklists. The use of checklist is to inform the people, and when they read the checklist, they will think, what can I do to avoid this situation? And the people won't have the checklist in emergency with them, but if they read the checklist several times, they will be ready. So it's a very good solution to prepare checklists for the worker and for the team leaders, and explain them to the people. And also, if you have special equipment, install checklist on site for the proper using of the equipment. That's an example for our rescue chamber. It's good to have a rescue chamber. If the people cannot operate the rescue chamber, it's for nothing. So we install in the rescue chamber such checklist how the rescue chamber is to be managed. Very important is the training. It's good to have fire extinguisher, but if the people are don't use it correctly, it's always for nothing. So you have to train your people how to stop quickly a fire, how to use exactly the fire extinguisher. And it's the same case for all the equipment. If you have other protection equipment, if you have self-rescuer, the people have to be trained for that. It seems to be simple, I have to say, but I don't know a lot of companies who are doing that. It seems to be difficult, but the contractor have to organize that. And the problem outside is the orientation of the firemen. So you have to train them on site. You have to make emergency exercise with the worker, with the fireman, with the ambulance, and you have to control this exercise. You have to place observer on key position, and after that you have to make a debriefing of the exercise and decide if you will to change emergency procedure or to change something in the emergency organization. And some advice for the training for the building of rescue and firefighting team. First thing, they have to be volunteers. If the people are not volunteers, they will not make a good job. But these people on site have been coached by professional firemen. And they should have time to train on site. It's during the work, you give people 2 hours to train, for example, per week, but you have to go on site at each position in the tunnel, and they have to be accustomed to the situation. And a very important thing, the fireman rescue team, when they are coming on a site during an intervention, the first thing they have to think is to think on their own safety. You have a good example here that it's an accident in a tunnel in operation, and before the fireman decide to take the people out of the car, they have to be sure that the car don't move, don't fall on the people working, on the fireman. So first thing is to stabilize, to be sure that the car is blocked, and after to save the people. That's very important. The fire is very, very dangerous. Not only the fire, the smoke is more dangerous than fire. Here you have an accident in Spain. It's not so far from the portal, and you can see here you have the fire. The firemen are very close to the fire, as the smoke is on the top. It seems to don't be dangerous, and in this situation it's not so dangerous. But if you are on the smoke, it's dangerous. It's exactly if you have a fire and no ventilation. It's I have to say in a distance of 300 meters of the fire, there is the smoke is on the top. You can go to the fire; it's not dangerous. And after. And because the temperature of the smoke is very high, and after a distance of 500 to 900 meters, the smoke falls down on the tunnel. At this point, it is dangerous. And if you have a ventilation system, a ventilation fluid, there is one safe side from the fire and a dangerous side. And the best solution is to have some shaft to evacuate the smoke. But normally you don't have that. But the standard situation in a tunnel, if you have a ventilation, you could have this situation. And here's some example of that exercises with not real smoke. But one of the problem you have, you cannot see some things, that's very dangerous. And one of the problem you have at the portal, there is smoke at the portal. And if you install your compressor for air supply of the rescue chamber directly at the portal, you will bring polluted air in your rescue chambers. So you have to think at that, and you have to install your compressor at a relatively big distance from the portal. I think more than 100 meters is good. But you have to think at that. Don't install, that's a very common mistake to install the compressor directly at the portal, and also for the ventilation. If the issue, normally we install the ventilation at the portal, and that's the standard system. But if you have a fire, you will bring polluted air in your system. And I said it's possible to go to the fire to make to stop it. And if you go with the fresh air, you can come at the beginning of the fire, at the beginning of the brand. You can go very close to the fire because the temperature is very low on this side, and you can approach the fire and try to stop it. And the problem we had when we are in a small tunnel, there is infrared radiation, and the problem, the power of a fire is enormous. When you have a truck fire, we speak in megawatt. It's very, very, very. It's a very high power. So it's very important to stop the fire very quickly. You can go to the fire at the beginning, at the initiation of the fire, and stop it. But after some minutes in a tunnel, you have an increase of the temperature because of the infrared radiation. The heat cannot go outside. The heat stays in the region of the fire. So it's very important to react quickly. So the people have to be trained to react quickly. And if it's not possible to stop the fire, the alarm has to be sent. And for sending the alarm, you have to have somebody at the other side to catch the alarm. It seems to be simple, but you have to organize something to catch the alarm and to send the alarm away. So you have to have a system, somebody who sends the alarm to all the people in the tunnel, to send the alarm to decide what to do with the ventilation, and to launch the rescue and firefighting forces. You have to give some instruction to people. So the fire alarm, first thing is to inform the colleagues. Don't go outside, but first of all, inform your colleagues. If you have oxygen self-rescuer, take it with you. Keep calm. It's not easy, but keep calm. Look where is the smoke, if there is smoke, where is the smoke is coming, and analyze quickly, try to analyze the situation. And after, try to go to a safe place. Normally it is one of the portals, but if there is rescue chamber, go to the rescue chamber, but try to go together, grouped. And when you are for example, in a rescue chamber, inform the people outside. If you should have a telephone, and inform the people outside we are there. And at that moment, wait for the instruction. I have to say, if you have a fire event in a tunnel, it will be a chaos. It's always the same. And so people outside the site management have to take some measure outside to reduce the chaos. First thing is to count the people, to know where are my people. That's very important. Another thing is avoid the entrance of curious onlooker on site. So organize people to block the road to don't have people. Manage the journalist. It's very strange how speed are the journalists, how they are informed. And if you have problem, try to manage the journalists. So decide, organize something to manage the journalist. For example, we have decision on the Lötschberg. As site manager, if there is such an event, I have 1 hour, 1 hour and a half to make a press conference. It was a decision. But don't let the journalists go everywhere in your site. And another thing, inform the families of the people. Because if you don't inform the family of your people, they will come on site if they are living in the region. And you have to manage the people too. Okay, conclusion. Fire emergency, safety management should be organized by professionals. It costs money, it costs time, it costs money. And the responsibility is by the site management, I have to say, by the client or by the site management of the contractor, but it's a direction level. And you have national regulation, that you have to look at your national regulation, and should be ready at any time. Don't rely only on Santa Barbara. Thank you very much for your attention.